Okay, this video is going to cover Chapter 1, Section 1, which is Lines in the Plane. This is from your actual book, so you'll get to access this through WebAssign, but tonight's homework will be a PDF until I'm there to walk you through the WebAssign process. Please make sure that at the end of the video you submit your notes for this video. So if you haven't already got that note shell open, make sure it's open so that you can be taking notes while the video is playing, and then submit it for a classwork grade at the end. If you need to at any time, pause that video, go ahead and do so. Just jump on up, pause the video so that everybody makes sure that they're copying the notes and understanding the material from today. So the good news is this is like literally lines in a plane, something that you've been doing for a long time. It should be completely review, maybe a refresher for those of you that are a little rusty. So we start with the slope of a line. So the slope is how steep a line is. Okay, it's the change in y over the change in x. The variable for slope is m. And if you're given 2 coordinate points, then you would find your slope by doing y2 minus y1 over x2 minus x1. So that would be if you were given 2 coordinate points, y2 minus y1 over x2 minus x1. This is also known as rise over run. There are 4 types of slope. Positive increases as you move from left to right. Negative decreases as you move from left to right. No slope or undefined slope is straight up and down. It happens when you have a vertical line. And slope equal to 0 is a horizontal line. So if you've ever been on a treadmill and you've kind of messed with the incline of that treadmill, you know that the higher the number of positive, the higher positive number, the higher that steepness is. If you had an inverted one and you went negative, then it would be like walking down a hill. If you are at on a flat treadmill, that's when your slope is at 0. And if you could somehow get your treadmill to go straight up and down, there would be no slope or undefined slope. If you think about it, there'd be nothing to grip onto, so there'd be no slope to grip onto. There are 3 types of equations we're going to use throughout the section. Slope-intercept form, which is probably the one we know the most. Y equals mx plus b, where m is the slope and b is the y-intercept. More accurately, 0b would be the y-intercept because it's a coordinate point. Point slope we use to plug values into, and that is y minus y1 equals m times x minus x1. And we plug in the point and the slope. So the point would be your x1, y1, and the slope would be your m. And then usually we change it to go back into slope-intercept form. And last but not least, standard form. Standard form is ax plus by equals c, where they are all whole numbers, so no decimals, no fractions. And x must be positive, so specifically ax, the coefficient on x has to be positive. The y can be negative, but the x has to be positive. So we very rarely plug information into this type of equation. We would plug into slope-intercept or point slope, and then it might ask you to put it into standard form, and that's when you would move it around to be variables on the same side, no decimals, no fractions, and x being positive. All right, this first example just says find the slope of the line with the given information. So question A gives you 2 coordinate points. It passes through negative 3, 2, and 5, 7, which means I'm going to use my y2 minus y1 over x2 minus x1. This could be my x1, my y1, my x2, my y2. So 7 minus 2 over negative 5 minus a negative 3, which becomes plus 3. And I get 5 over negative 2. Now that negative can go out front. It can be in the top with the 5, in the bottom with the 2, any of those spots. Okay, then we get B, and this has a line with points plotted on a coordinate grid. So you can either use these 2 points in the same way we used this example, or you could literally count your rise and your run. If I'm counting from this point to this point, then my rise is down. So negative 1, 2, 3, 4. My run is to the right, 1, 2, 3, 4. So it would be positive. And my rise over run would be negative 4 over 4, which is reduced to negative 1. I can also reverse the order on that count. So I could pick either point to start with. I could start with this point and work my way up to this point. So my rise would be 1, 2, 3, 4. And my run, 1, 2, 3, 4 to the left. So it's negative. Now it's 4 over negative 4, which still simplifies to be negative 1. So it doesn't matter which way you count, as long as you always put your rise over your run. Okay, graphing using a point and slope. So when we're given a graph in point slope format, we're going to start on the y-axis at the value that's b, which is your y-intercept. And then we're going to use the slope to find the next points. So we'll count the rise over run from your y-intercept. Two special cases are vertical lines and horizontal lines. Vertical lines, which go up and down, have an equation, x equals, and there's a number, and there's no y in this equation. So if I had a line that crossed through where x was 2, a vertical line, my equation would be x equals 2. And remember, this has undefined slope. Horizontal lines, point left and right, have an equation that's a y equals a number, and there's no x. So this time it would be horizontal. Let's say that's now negative 2, and this would be y equals negative 2. The slope there would be 0. All right, so example 2, find the slope, the y-intercept, and then graph. So we're going to put these all on the same coordinate grid, which means we want to label them. A says y equals 2x minus 1, so my slope is 2. My b is negative 1, so my y-intercept is 0, negative 1. I'm going to start there at negative 1 on the y-axis. And then slope being 2 means that my rise is 2, my run is 1. So you always want to put slope in fraction form before you graph it. So I'm going to go up 2 to the right 1, or I could go down 2 and to the left 1. You can invert the signs there. And then draw your line. So this would be A. The slope of B is negative 3, which would be negative 3 over 1. The B is 2, which means my y-intercept is 0, 2. I go up to positive 2, plot my y-intercept, and I go down 3 and to the right 1, or up 3 and to the left 1. And that's B. Now C is in standard form. So I could find intercepts here. I could plug in zeros for the x and zeros for the y to get the x and y intercepts and connect them that way. But because it's already telling me I need to find the slope and the y-intercept, I might as well just move this into slope-intercept form. So I'm going to subtract the 3x. I get 2y equals negative 3x plus 6. And then divide everything by 2. Don't forget all of that gets it. So don't forget about the 6. Y would equal negative 3 halves x plus 3. So now my y-intercept, well, my slope is negative 3 halves. And my y-intercept is 0, 3. So I start at 0, 3, and I use my slope -3 over 2, or up 3, left 2. And there's C. So you want these to be nice straight lines. Obviously, Notability, it's easy to make them when you tap and hold it. On a test, you can use your straight edge from your ID, something like that. All right. Example 3 says, find the equation of a line with the given information. So now we're looking at an equation. It doesn't tell us what format to put it in, which means we'll put it in y equals mx plus b. So unless it says to put it in standard form, I'll keep it in this format. Now I have two choices. I can either take this slope and point, plug it into the y equals mx plus b, solve for b, and then plug back in the slope and the b. Or I can plug it into point slope. So I'm going to show you both ways by using example A and then example B. So let me start with this one. Y equals mx plus b. This is my x, this is my y, and this is my m. So 7 equals 2 times x, which is -1, plus b. 7 equals -2 plus b, and b would equal 9. Now I have to take and plug back in the b and the m. So y equals m, which is 2, x plus b, which is positive 9. And there's the equation of a line. Now let's say I wanted to use that in point slope. Y minus y1 equals m times x minus x1. This time, I just plug the information in once. The y stays the y. This would be x1, y1. So the y1 is 7. The m is 2. The x stays as x. The x1 is a -1. So minus a -1 here becomes plus 1. So then I could distribute the 2. Y minus 7 equals 2x plus 2. And then add the 7, y equals 2x plus 9. Same answer, different format, up to you how you do it. All right, B gives the same information, the slope and a point. So when I'm given that information, I tend to choose the second method, which is point slope. Just be prepared that sometimes it's easier to plug it into y equals mx plus b, like if you're given the if you're given the slope and the y-intercept, obviously it's easier to plug in there. So you can always bounce back and forth between the two. All right, so with this one, I'm going to plug it into point slope. So this is my x1, this is my y1. Y minus y1 equals m, x minus x1. Y minus a -2 becomes plus 2 equals -3/4, x minus 3. I'm going to distribute the -3/4. And it becomes a positive 9/4. Then I'm going to subtract the 2. So y equals -3/4 x. And then 9/4 minus 2 over 1. Multiply by the 4, give it the least common denominator. Becomes -8/4. So 9/4 minus 8/4 becomes 1/4. And there's the equation. C is not giving you the point and the slope. Now it's 2 points. So the first thing we got to do is find the slope. So I'm going to use my x1, y1, x2, y2, and 7 minus 1 over -8 minus a -8, which becomes plus 8. And I get 6 over 0. Hopefully we remember that if the 0 is in the bottom, this is undefined, which means I can't even plug it into an equation. I have to know that a line with undefined slope is vertical, and a vertical line has an x equals equation. So now it's like, well, which x do I grab? If you look at the two x's, they're the same. So this would be x equals -8. If it was a vertical line, the slope would be 0, and it would be a y equals, and both of the y's would be the same. So if you can catch it from the beginning, you don't necessarily have to go through all that work. All right, last thing we're going to talk about, we're going to apply it in a couple different ways, but this is what the last topic we're going to talk about is parallel and perpendicular lines. So parallel lines are lines that have the same slope. So these are parallel lines that are never going to intersect, okay? And they have the same slope. They have the same rise and the same run. Perpendicular lines are lines that have slopes that are opposite reciprocals from each other. So opposite meaning if one's positive, the other's negative. If one's negative, the other's positive. And reciprocal, meaning if something was like 2/3, then the reciprocal would be 3/2. So we flip it. So not only do we change the sign, but we also flip it. So you need both opposite and reciprocal. And these would be perpendicular lines. So they form a right angle. Okay, so the first way we're going to apply this is just by looking at lines or either by equation or by coordinate points and determining if they're parallel, perpendicular, or neither. So again, parallel would be if they have the same slope, perpendicular, opposite, and reciprocal, and neither would be neither. So if you look at A, the notation is just line 1 and line 2. So line 1 has this equation. Line 2 has this equation. From these equations, we want to find our slope. Slope of line 1 would be whatever's in front of that x, so it would be 2. Slope of line 2 would be whatever's in front of that x, which is -2. They're obviously not the same. They are opposites, but they are not reciprocals, so this is a neither situation. If you wanted to graph it so you could get a visual on it, you can feel free, but you don't need to. All right, B. Again, they're in slope-intercept form, so I'm just looking at their slopes. Slope of line 1 is 1/3. Slope of line 2 is -3. These are opposite reciprocals, which means that this is perpendicular. And the last one is not giving me an equation, but it does give me the points. So the first thing I have to do is actually find my slope and then compare it. So I'm going to do rise over run here, or y2 minus y1. Nine minus a -1 over 5 minus 0. This becomes plus, and that's 10 over 5, which is 2. This one, 1 minus 3 over 4 minus 0, -2 over 4, which is -1/2. Now they're not the same, and again, this time they're also opposite and reciprocal, which means these lines would also be perpendicular. Last up, and this is where people tend to get the most confused. So if you have found yourself zoning out, please refocus in on example 5. These are not difficult questions, but people make some silly mistakes here. So this is write the equation of a line through the given point that is A parallel to and B perpendicular to the given line. That means there's 2 questions here. A, find the equation of a line with this information that is parallel to that line. B, find the equation of a line that is perpendicular to this line. But both cases, you're using this point, the point that it passes through. So what I need from my original equation, it's just its slope. If I have 3x plus 4y equals 7, all I need from it is its slope, and then I'm done with that equation. There's 2 ways to find the slope of this line. One is put it into slope-intercept form. So 4y, subtract the 3x, would equal -3x plus 7, divide both sides by 4. And there's my slope. So the slope of the original line is -3/4. A shortcut to finding slope when an equation is given in standard form like this is ax plus by equals c, is m equals negative a over b. So negative 3 over 4. That's how you can use a shortcut if it's in standard form to find the equation of that. To find the slope of that line. All right, now I know the slope of that line. I need to find the slope of a line parallel to it. So remember, parallel has same slope. This would be slope negative 3/4. That passes through negative 2/3 and 7/8. And then I'm going to find the slope of a line that's perpendicular to it. So opposite reciprocal, which would be positive 4/3. That passes through negative 2/3 and 7/8. So let's start with that first one. This would be my x1, y1. I'm going to plug it into point slope. Y minus 7/8 equals negative 3/4. X minus a negative 2/3 becomes plus 2/3. Distribute the fraction. Negative 3/4 x. And then negative 3/4 times 2/3. The 3's would cancel. The 2 would go into the 4 twice. So I get negative 1/2. So again, that was a negative 3/4 times 2/3. I can cross cancel. 2 goes into 4 twice, and the 3's cancel, and I end up with that negative 1/2. Still have to add the 7/8. So I get y equals negative 3/4 x, and then I want to combine these two. So I'd have to multiply by 4. I'd get negative 4/8 plus 7/8, which is positive 3/8. So yes, you will see fractions in this kinds of stuff. You can handle it, I promise. All right, now B is the perpendicular one. So now you're dealing with the slope that's 4/3. Same coordinate point though. X1, Y1 is still negative 2/3 and 7/8. So Y minus 7/8 equals 4/3 X minus a negative 2/3, which becomes plus 2/3. Distribute your 4/3. Y minus 7/8 equals 4/3 x. Multiply these out, and you get 8/9. Add the 7/8. Y equals 4/3 x. And I got to combine this. And ew, we have to change both denominators. So I'm going to multiply by 8 and 8, 64 over 72. And I'm going to multiply by 9 and 9, 63 over 72. They're both positive, so this is plus 127 over 72. If you could simplify it, you would. You don't need it in mixed number form. Unless you're going to graph this line, then obviously you would want it in mixed number form. But as it is fine for the answer. So be careful with this perpendicular one. What the most common mistake made on this is once you find your parallel one, people literally grab this B with this slope, which is not right. The only thing that you get from that original line is the slope of it, then you're done with it, and then you're going to get two completely separate y-intercepts. You just use the parallel or the perpendicular slope. All right, so that wraps up 1-1. Remember that you need to submit your notes to the classwork assignment so you can get credit for that. And then you can use the rest of the time to start the 1-1 homework, which is due tomorrow. Have a fantastic day, guys.